Okay, we are in our last part of chapter 3. Almost made it. So, now we're talking about neuropsychological factors. The executive function is housed in our frontal lobe and controls our higher level cognitive processes, which include reasoning, logic or problem solving, abstract thinking, self-control. And we find there is a link, not surprisingly, between deficient or not as good functioning of the executive function and antisocial behavior. So if there's some problem with reasoning, self-control, problem solving, and logic, if there's a problem, we are more likely to have some antisocial behavior. So let's talk about risk-taking. Not surprisingly, if you think back to your own adolescent times, which might not have been too long ago for some of you, it increases in adolescence. So we're more likely to take risks in adolescence compared to when we were a child, and certainly also compared to when we are adults and out of adolescence. What are some examples? Usually I ask this in class and people aren't really sure, and I say, what is this one right here? Teenage pregnancy, yes? So substance abuse, reckless driving, risky sexual behavior that might lead to a child, but they think somehow it won't happen to them. And depending on your peer group, that can be very related to more likely to take those risk-taking behaviors. So if you hang out with friends that are more likely to do these types of behaviors, you're more likely to do those behaviors. Not surprisingly, since we're talking about this here, it's a major factor with regards to delinquency, violent, and antisocial behavior. Risk-taking again. Our vulnerability to risk-taking results from high levels of sensation seeking and low impulse control. And I'm going to be going over a theory on the next slide or two to talk about this a little bit more. And we find that this is the most, or it is most at issue in mid-adolescence. And again, this is linking back to the theory I'm going to be talking about on the next slides, but high levels of sensation seeking and low ability to control our impulses. And I found these, I think I did adolescent risk-taking, and this came out, so, standing or car surfing, if you will, on the top of a car, going who knows how fast and taking turns where one wrong turn or you lose your balance, hit your head and you could die, texting and driving, or riding a bicycle with a garbage can on your head. That apparently is also under risk-taking, teenage risk-taking on Google when I made this. It slowly decreases and ends at 25, about 25. Why? Because that is when our prefrontal cortex is fully developed. So remember I said your frontal cortex, the frontal lobe of your brain isn't fully developed until your mid-20s, and so this is going to slowly decrease until that is fully developed. Okay, so here is our model or theory, if you will. We have these two systems, so just watch this with me for a moment to try and understand. So we've got our socio-emotional system and our cognitive control system. Our socio-emotional system is concerned with rewards, emotional arousal, and stimulation seeking. So we're interested in getting that kind of arousal and rush and reward. It's very sensitive and easily aroused, and it matures when we're about 14. So that's our mid-adolescence. Next, we have our cognitive control, which houses our executive function, which we talked about a few slides ago. And this matures in young adulthood, so that's our mid-20s. So this gap in maturities, by gap in maturities, I mean 14 to young adulthood, mid-20s, so 14 to mid-20s here, is the period of heightened vulnerability to risk-taking. So let's think about this. Our socio-emotional system is fully aroused around 14. We want the rewards, we're seeking stimulation, but we're not able to stop ourselves and really think through the potential problems and troubles that we can encounter until we're, again, mid-20s, young adulthood. So this one is rearing to go, looking for that stimulation, seeking, and rewards, and instead, we're not able to fully stop ourselves until our frontal lobe is fully developed. So gap in maturities between 14 and mid-20s is the period of heightened vulnerability to risk-taking. So dual systems model, these are our two systems or dual systems, and explains adolescent risk-taking. How? By stating that our socio-emotional system is fully developed and is seeking rewards and stimulation early or mid-adolescence, but our brain frontal, prefrontal cortex or executive function isn't able to stop us or help us think things through as clearly because our frontal lobe is not developed completely until we're in our mid-20s. So let's give ourselves some evidence of this. Usually it's fun to guess this in class. What percentage of teen boys admit to criminal offenses? So take a moment and think about it. 0%? No. Higher than that. What are we thinking? High, middle? It's pretty high. So about 90% are admitting to criminal offenses, and think back to what we're even expecting them to admit to if it's a self-report survey. Think back to chapter 1, and we're still getting really high admittance there. So the problem with, I guess, this age, it's not with the theory, it's really with this age, is that teens know the risks. They know the problems here. So even if we're talking about risky sexual behaviors or saying no to drugs or something like that, we know the risks that are there. We just have difficulty controlling those behaviors at this age because our executive function isn't fully developed. So kind of wrapping up this chapter, biology is somewhat controversial when we're talking about criminal behavior. It implies that there are issues that are going to be present throughout people's lives that are present at birth or even before birth. So we could say something like, what's the use of trying to change anything, and get a little bit hopeless. Beyond that, it's transmitted from one generation to the next. So could we perhaps at some point say your mom and or dad is in prison, and so we're going to keep extra special eye on you, or who knows what? Or is that mean that you're immune to treatment and we should just give up on you altogether? No, it's not saying these things. As we discussed a little bit earlier, it's all about biology maybe putting us at greater risk, but that doesn't mean that it takes hold. So we have that turning on and off based on our environment that was talked about in one of the videos and I talked about earlier. And so it's not completely giving away responsibility. So again, it's not removing criminal responsibility, though some people state that with this point of view, because if it's all biological, there's not anything we can change. So I guess they just do what they're biologically programmed to do. Again, that could be a point of view, but that's not what we're stating because biology or genes doesn't explain everything. So because of that, well, maybe not just because of that, but our court system hasn't really bought into this to that extent. So biological defenses rarely work at trial, meaning, well, I have the genes, so it's okay that I killed this person because I couldn't help it. No, our court system is not allowing that to happen for the most part, because we still have free will. And we'll talk more about criminal responsibility when we get to chapter 8, talking about competency and insanity. But basically, just because you have this biological issue or biological risk factor doesn't mean that you didn't have a part in it yourself, that you didn't have free will, that you could have stopped yourself. So environment's important, but so are our social factors. We learned about some of those in chapter 2, and we're going to continue to learn about them in chapter 4, more psychological factors, I guess, and environmental. So they're still important regardless of biology also being important, because they can turn on and off our genetic factors. So remember we talked about before with maybe we have the warrior gene, but we're raised in a good home, and so the warrior gene doesn't actually get turned on. Just because you have the gene doesn't mean it's turned on, so to speak. Also with plasticity that we discussed not too long ago, and our biological defenses rarely work at trial and are not an excuse for responsibility. Sometimes they do work. So there have been instances where a warrior gene argument has been successful at trial. And there's a short video about the Dan White case and the Twinkie defense. So go ahead and watch that. That talks about it, but by and large, biological defenses are not going to work at trial. Very rarely do they work, and these are a few examples, but by and large, they do not work at trial. And that is it. Hope you enjoyed chapter 3, and as always, email me any questions that you have.